Assalamualaikum warahmatullahi wabarakatuh and very good afternoon.
Waalaikumsalam, Doktor.
Salam.
So today we will continue our next chapter because we already finished our last chapter, which is part A and part B. Last chapter, which is chapter number 3. So this is chapter number 4. So previously we covered imperfection. So from there we know that we have several type of defect or imperfection. We have point defects, we have planar defects, okay. Then we have volume defects. So we have linear defects. So from there we will know the arrangement of atom, including the impurities and some of the categories of point defects. So whatever the situation is, I think you will be able to describe, draw the mechanism, okay, of the defects. So today we will continue to chapter number 4. In chapter number 4, we divided into two parts, part A and part B. So before we go through, let's log in your attendance for 6th of April. In this part, in this chapter, we have two parts, part A and part B. For part A, basically, we will deal with the this one, mechanical properties and terminology, stress and strain. Okay, this is the basic of the material. Okay, especially for the metal, when we apply various load, and we would like to know the what is happening to the deformation to the material or deformation to the metals in terms of length, from the original length to the final length to the new length. So and then in terms of the change of the structural from the atomic point of view, and also from the physical shape, okay, change. And then we go for the part B, which is concept of stress and strain and material testing. So in this part B, we will focus more on the material testing. So from testing, we will can analyze which material is according to what in terms of properties, okay, especially for the mechanical properties. So for today, we will focus on the mechanical properties and terminology, stress and strain. Okay, basically, we will look at the concept of the strain and stress. Actually, we will discuss from the point of stress and strain if we have a static load. Okay, the various load given, changes of load, okay, slowly along the time. Okay, so when we apply the load at a certain time and the change of load, and it's also produce a changing at the certain area uniformly over a cross-sectional area, and from there we can analyze in terms of mechanical behavior. Okay, in this case, when we call behavior is when we deal with the behavior, maybe we can express is in the term of properties. Okay, so from there we can have information of stress, strain. Okay, so from there we will have further information of the tension, compression, and also shear. Okay, so if we given load, the change of load over time into a cross-sectional area, so it will produce will give more information in terms of tension and compression. From there, we will can analyze by using a graph. Okay, we can produce a stress strain graph, or we call it stress strain curve. Okay, from there we will see what will happen to the load years, to the length, and also to the change of shape. Okay, and also we will deal with the various term. Okay, we have a yield strength, upper yield strength, and then we have a making point or something like that. Okay, after this we will see. Okay. So for the when we apply a force or we give a load, there is a two possibility. The first one is tension. Okay, and then the second one is in compression. Okay, you already learn in the static. So there is a force applied two ways, which is a tension, whereby we give the outside, or we apply a tension away from the rod or material. So for the compression, we will compress. Okay, opposite direction. Okay, so the value, if we apply at the both end, is the same value, it will produce the compression. And then the change of direction, okay, we can see there is applied of the Newton's third law. Okay, is action and reaction have the same value but the opposite direction. Okay, so when we give this applied force to the material, or especially for the metal, okay, the deformation will take place. Okay, so in tension we can see that there is a elongation of the cylinder from the original, which is short. Okay, after we give a tension, it will final result a little bit longer. Okay, for the compression, okay, basically the deformation takes place whereby the original length is long, okay, at a certain length, and final result will be the shorter. Okay, so the compression takes place, and we can see the deformation in term of length, and also deformation in term of physical shape. Okay, and then from there deformation will take place is according to the load given. Okay, once we give an extra load, the tension or compression, it will behave as something different. Okay, so after this we will see a deformation in term of elastic deformation and also plastic deformation. Okay, so so for the stress and strain, basically stress we can calculate or define as a force per unit area, whereby the sigma is equivalent to the F over A, whereby F is force, if of course in Newton, over A is area, is a meter squared. So in the SI unit, standard unit, we will have Newton per meter squared, or other term we can call it in Pascal. A various abbreviation of the Pascal, we have kilopascal, megapascal, gigapascal. Okay, so it depends on how big load is given on the surface area. So for the tension, or other term they call it tensile. Okay, the tensile takes place whereby the cylinder or the material will start at the final stage more longer. Okay, And for the compressive compression will force make the body shorter. Okay. So for the if we look at the different material with the different surface area, let's say we have two surface area, the smaller one and the bigger one, but we want to look at the what happened when we apply the same force, okay, the same load, but the different surface area. Okay, if we can see, if we apply the same force at the different surface area, we can conclude that have the smallest uh, the smallest metal, okay, will behave the large stress, okay, and if compared to the bigger surface area of the metal, okay, so we will indicate that for the bigger surface area, by using the same load, it will produce a small stress can be calculated by using the formula, okay, this formula. So then if we look at the new formula, we have stress over strain, so it will produce a large value. So that's mean the metal is very strong. Okay. If we talk about material, this material is quite strong. If we look at the stress over strain, okay. If you look at the this value is small compared to others, okay, it will portray as a weak material, okay. So what about strain? The strain is we look at the deformation per unit of original length. So in this case, we have this setup of cylinder. The original length is L. So and then we applied a tensional force given the load, and the final result, the cylinder become more longer, and as we can see that at this point C here, there is a small difference between length at points from the left hand side cylinder here. So as you can see, there is a delta L here, this one. So the delta L is the difference between the final length to the original length. So in order to calculate the value of strain, you can use the epsilon equal to delta L over L. Okay, in this case, for the strain, okay, for the unit, there is no unit for the strain because of the delta L is in SI unit in meter, divide by meter, the epsilon, which is the strain, is unitless. Okay, so normal strain, they call it basically for the extensional strain. Okay, strain. Okay, so we have stress and also we have strain with two different formula. Okay, if we combine them, we can produce they call it modulus Young. Okay, so in this case, we have delta L after we produce applied a load. Okay, and then it will, from this case, we can see a very large amount of different delta L. It will produce a large strain. Okay, if we compare to this figure, there is a very least little changes of delta L. It will produce a small strain. Okay, and if we can use the formula to produce this kind of thing, whether this large strain or small strain. Okay. For linear dimension, basically when we have the value of stress, okay, and then we have the value of strain, okay, by using the same given load and what will happen to the length, and finally we can calculate as a Young modulus Y. Okay, so now let's see to the type of mechanical properties. Okay, so after this, we will look at the type of mechanical properties that we want to discuss. But a lot of mechanical properties actually, if we want to discuss, but only very important mechanical properties we will discuss. Okay. So basically, the type of mechanical properties is defined as properties which complete define its behavior under action of external load or force. Okay, when we give external load, there is changes of behavior of metal. So from there, we can prescribe as a properties. Okay, so the properties which associate actually based on the resist failure and behavior under action of external load. Okay, so then the knowledge we want to know about its properties, or especially in mechanical properties, we would like to have the information about the application. So in terms of different application, we would like to have a different material that suit from the application. So that we have a various material to be selected in order to make it to suitable for the application. Okay. Among the important mechanical properties are we have until 12 mechanical properties. So the main important, maybe we will discuss on most of the strength, hardness, toughness, elasticity. Okay, and then we have also malleability, machinability, weldability, castability, resilient. Okay, so there is a many term that you discover here. So there is a more on his behavior according to the strength, what is different when we talk about the hardness between the ductility or something like that. Okay. So in there is a 12 mechanical properties, but maybe if we can understand in Malay, okay, the strength is basically kuat, kekuatan. Hardness is kekerasan. Okay, toughness is kelihatan. Okay, creep is rayapan. Okay, and then ductile is mulu. Okay, and then elastic is that from the English word is elastic, and then plastic is plastic. Brittle is rapuh. Malleability is can be bendable, something like that. And then resilient is ketahanan. Okay. So there are 12 mechanical properties. After this, we will see the important thing of this. Okay, and then including the testing. Okay, before we understand of the properties, we need to test the material. Okay, and then we will discuss on various of material according to its behavior. Okay, so in this case, we will see the term of this, what is the meaning of this term. Okay, and also we will go for the testing. Okay. Okay, for the strength, is basically ability of material to withstand or support external force. Okay, so in strength is, okay, if you can see from here, kekuatan. Okay, so that ability of material to withstand. Okay, so that's mean when we introduce external force, it will can be withstand. Okay, load without rupture. Okay, that's mean rupture is like if we talk about the shape deformation, the rupture will at the final stage it will break. Okay, something like that. Okay, many type of strength. We will talk about tensile, compressive, bending, shear, torsional. Okay, this is a strength. Okay, so when we talk about the strength, is basically we will talk about this item. Okay, and then we have hardness. Okay, the ability of material to resist deformation by abrasion. Okay, so and also indentation or penetration and scratching by harder bodies. So the hardness is basically can associate with the test. Okay, we have a hardness test. Okay, the hardness test is basically we talk about, we give the impact of the by using a force on the metal, so that there is a deformation of metal after the impact. We will study, okay, from there. So the hardness maybe in this case the ability to resist of the indentation, penetration, or scratching by other material. Okay, so when we need to understand the hardness because of the application. So some of the material we need extra hardness because of the friction between other metal. Okay, it will produce a wear and tear. So the hardness is play important role. Okay, because of the frictional, okay, the between the roughness of the surface, okay, from the other material. And then we have ductility. Okay, for the ductility is ability of material to undergo appreciable plastic deformation before rupture. Okay, this one ductility is like in this case, if we look at the in Malay, ductility is mulu. Okay, mulu it will produce certain deformation starting from elastic and then up to the elastic, up to the plastic deformation. So when we like other metal, when we give extra load, it will deform at a certain diameter, and finally it will make longer, macam spring. At a certain stage, we apply load and we leave the load, it will go back to its original position. Okay, so once we give external load until its limit, the boundary of elastic, it will go to the plastic deformation. Okay, the plastic deformation, when we take up the load, the deformation is permanent. So the spring cannot spring back to original position. Something happened to the metal. So the ductility is whereby the material to undergo plastic deformation before putus, okay, before rupture. Okay, okay, can be drawn into wire and also the elongation. Okay, so then we have toughness. Okay, this one, toughness is ability of material to absorb maximum energy, okay, up to fracture. Okay, so there is a toughness in terms of we want to apply a force for the cutting of the materials. Okay, maybe we want to have a to test the cutting machine or something, so that the harder, the very tough material will possess very hard to cut, something like that. Okay, must be strong and ductile to be tough. Okay, and then show ability to withstand impact. Okay, so and then we have this one is an impact. We also have the impact test. Okay, so testing for the impact of the certain material. Okay, behave mechanical properties such as toughness, okay, hardness or something like that. So the value increase when temperature increase, decrease when the temperature increase. Okay, this one if we apply a temperature at higher temperature, the toughness of the material, it will decrease. Okay, due to the if we discuss on the atomic arrangement, okay, and the metal will start to reach at the melting point or something like that, okay, the ability of the properties of toughness is decreased. And then there is some crack propagation, slough or impedance. Okay, so in this, for the toughness, maybe we can analyze according to the its behavior due to the exposed to the temperature and also cracking produced, okay, during the impact. Okay, then we have elasticity. Okay, elasticity is ability of material to retain to its original position or shape. Okay, in this case, I previously I already mentioned about the spring. When we give a load, whereby the load is in the range of the limit of its elasticity. When we remove the load, it will spring back to original position. Okay, so this one is elasticity, whereby most metal show is elasticity. Okay, and then the plasticity, the ability of material to experience permanent deformation. Okay, so after the limit of the elasticity, the material will behave the plasticity. Okay, so when we apply the load is higher than the limit of the elasticity, the original shape of spring or metal, it will deform. Okay, deform to other shape. Okay, so at that point there is a, we call it the deformation impermanent. Okay, whereby the material cannot spring back to the original position or the original shape. Okay, and then at the final stage, we will see the material we will fracture, okay, or a break, okay, something like that. Okay, most material possess good plasticity. So when we have the information about the elastic and plasticity, so we can manipulate the formation, the permanent deformation. Okay, so including the behavior of atomic arrangement, or we manipulate by using introducing other element inside, okay, to make it plasticity in the different form. Okay, so that other or foreign material or impurities play important role in this part. Okay. Then we have machinability. Okay, the machinability is ability of metal to be cut or removed by cutting tools in various machining operations. So nowadays, previously we mainly use of the stainless steel, okay, and then because of the ability to hardness, okay, if compared to other material, and also can be machinable, okay, so that we can use a cutting tool to cut, okay, at the minimum cost. Okay, nowadays many materials they use aluminium, okay, because of the aluminium is available and can be affordable at a cheap price, and also many cutting materials support this kind of metal. Okay, and also the research mainly tackle the issue of the aluminium to be used in the mass production. So machinability is whereby we can use a cutting tool, okay, to cut, okay, in the if in easiest way, along with the low cost or something like that. Okay, and then we have weldability, ability of two similar or dissimilar metals to be joined by fusion or with or without filler. This one, this material can be joined together by using a welding machine. Okay, so whether the techniques okay, other technique, welding techniques, whereby if this material can be joined together by using a welding machine, this one we call it a weldability. Okay. And then we have a castability, okay, ability to form into a different shape or size from the liquid state. So the materials that form when we heat at a certain melting point, it will melt to become a liquid, and then we pour in the mold for different shape that we want according to the application, and it will produce a shape that we want. So at this point we call it a castability, okay, casting, okay. And then we will go for the tensile test. Before we will go for the tensile test, okay, we will go for the mechanical test of metal. So there are a lot of techniques that can be used to test metal according to the mechanical properties. Okay, in this case, we will see the mechanical properties of metal basically established by the conducting test. Okay, various testing machine. Okay, so we have the hardness, mechanical properties of hardness, mechanical properties of tensile, mechanical properties of ductile, all of the mechanical properties is basically from the testing. Okay, and then we have a type of mechanical tests. There are several mechanical tests, which is a tensile test. Then we have a hardness test. Okay, the tensile test, we will get information. We analyze of the tensile, compression, shear, and then we have a hardness test. Okay, we have impact test, we have a compressive test, and also we have fatigue test, creep test. So I think not all of these tests we will go further, but the main basic test we will discuss. Okay, but for the different, let's say we have a hardness test, we also have a different style of test. Okay, by using a different method. Okay, so a lot of tests is available, so we will just to understand the main important of the test. Okay, let's see of the tensile test. Okay, for the tensile test is basically we have the machine. We have the machine is basically we want to test of the tension testing. Okay, so we have given the applied external load. We have the tension. Okay, so supposed to be the sample will finally will have a extra longer, and from the certain initial length to the final length is longer and finally break. Okay, the process is whereby we need to understand from the initial position until the break. Okay, whereby we will produce a stress strain curve. Okay, after this we will see the stress strain curve during the process of the tensile test, which is or they call it stress strain test. Okay, three ways of load application. Okay, the one is a tension, and then second one is shear, and the third one is compression. Okay, the tension we can see from the original position until it's break. Okay, most common mechanical strength strains perform in tension. Okay, so because of we can observe the rupture or break at a certain point. Okay, the objective is basically to look at the elastic limit. Okay, because of the metal behave of the elastic and also plastic. There is a certain limit of elastic, so that we would like to know at the what load at a certain load or certain strain given, and also the point of the yield strength. Okay, where the point of yield point. Okay, after this we will see the graph produced during the process. Okay, and then also the ultimate tensile strength. Okay, and then the percentage of elongation of reducing of the area. Okay, this one you will see. Okay. Okay. Before we test the by using a tensile test, we need to have a very dedicated template of the specimen. They call it specimen. We need to produce a specimen according to the machine. Okay, some of the specimen, the shape is something like this. Okay, some of the specimen is something like this. Okay, it's depend on the machine use. Okay, so the specimen they call it standard specimen. Okay, whereby if something like this in the circular, or we have a kind of this cylinder. Okay, we have a certain standard cross-sectional area, so need to be used. Okay, so we have a sectional diameter of different something like this, and also the procedure is basically specimen held in holding grip of apparatus, whereby there is a grip of the upper and lower grip. Okay, because of the given external load at the two different end. Okay, at the different direction. So, and then load applied gradually as a constant rate. Okay, and then there is a machine program that we can increase the load or the force according to the time given. Okay, so we will introduce a gradual of a constant load according to the time. Okay, so this constant rate is basically the force produced, external force given at the small number of time. Okay, so the specimen will be elongated until it break. Okay, so we can see from the deformation at the center of this sample or specimen, and then we will measure by the extensometer. So I already share with you in the e-learning that the process of the tensile test, we have a machine, and then starting from the load of the specimen until the final of the data produced. Okay, for the data recorded is basically we have the value of force produced, and also the we have the area, the change of area, and then we calculate the value of the stress, and also we calculate the value of strain. Okay, so here is in the actually, if we have this machine, we can do experiment. Okay, to look at the what will happen to the force produced, and also produce a graph by looking at the force, by looking at the time, by looking at the stress and strain curve. Okay, so from there we will understand what will happen to the metal. Okay, and this is the standard tensile specimen. Okay, basically there is the necking area, the A area, B areas. Okay, whereby the standard cross-sectional area is given. Okay, according this depend on the machine. Okay, some of the machine will use a different standard. Okay, Okay, but this one I just to show you there is a standard. Okay, it depends on the machine. Okay, and then we have a tensile test apparatus diagram is something like this, and then we can see the specimen, okay, position here, the clamping at the two end, and then there is a moving part here to produce a external load, and finally we can see there is a deformation takes place at the this position in the middle, okay, because of this position is the highly critical area whereby possible to break at this point. Okay, for the stress strain curve of the tensile stress is basically something like this. As you can see, different material will behave different curve. Okay, so after this, maybe we can see a different, if you can compare with the different steel, rubber or something like that. So it will show a different curve. This y-axis is a stress. Okay, the x-axis is a strain. Okay, from there, the information, the point produced, and um, we can make a projection. The curve is something like this. Okay, so the term we have at this point we call it a yield stress. Okay, the value, and then we have at this maximum y value, we call it maximum stress. Okay, and then the information of fracture is somewhere here, whereby the necking, the process of the break of the material. Okay, as you can see from here at this position, okay, this position whereby the original of the standard sample, and you will can see at this in the middle slowly deform and finally break. Okay. Yeah. So during the process, they will record by using machine. So we will record the amount of deformation, strain, okay, and also the stress. And finally, we can see from the computers, it will produce a graph, okay, something like this. Okay, the process. Okay, and then if we have the value of stress and value of strain, we can calculate the value of modulus of elasticity or modulus Young. Okay, and then we have the stress strain curve. Various material will behave different curve. Okay, so other detailed information. Okay, we have something like this. Okay, whereby we have the elastic deformation area. Okay, in this area, and also we have the plastic deformation area, this area, and finally this necking area. Okay, the elastic deformation whereby at a certain stress, whereby at yield point, okay, when we have this one is a limit of the elastic deformation. Okay, when we apply more load until it's over the limit of the elastic deformation, the metal will not spring it back to the original position. It will go for the plastic deformation. And when it's come to the plastic deformation, mainly we call it a permanent deformation. Okay, so this is the area of the plastic deformation, and finally necking process at this point whereby the fracture or the breaking happen. Okay, so this is the different curve according to the different material used. Okay, we can see steel, the curve is something like this. Okay, and we have a concrete. Okay, behave as something like this. Okay, and also we have a glass, okay, whereby the glass is something like this. Okay, at a certain point there is a no plastic deformation, and after the elastic deformation it will automatically break. Okay, no plastic deformation. Okay, in this case of the steel also happen from the previous slide I already talk about. Okay, and this one is a rubber. You can see there is a kind of curve with something like this. Okay, so there are several terms that can be discussed. Okay, so some of the term the steel deformation is something like this. We have at a certain point is will to the plastic, from the elastic to the plastic deformation. We have the upper yield point extension, and lower yield point. Certain metal, okay, certain material behave is something like this. So we have the term of yield point. We have elastic region, plastic region. We have ultimate strength or maximum strength, okay, or maximum stress, okay, something like this. Okay, and then the elongation, okay, the ultimate elongation. Okay, this is term that you need to know. Okay, so I don't want to highlight about this information, so I give you this as a assignment 1, so that you can go to search about the information, what will happen from point O to point A to point B. At that position, you need to discuss detail on what happened in terms of the shape, okay, deformation takes place. Okay, okay, the process, you need to explain about the deformation process, starting from 0 to A to B, B to C, C to D. Okay, and also you need to draw what will happen to the material. Okay, and if you have a term to discuss, please define the terms. Okay, let's say we have a maximum stress. What is the meaning of maximum stress? Fracture, what is the meaning of fracture? The yield stress, at which point we need to give the definition. Okay, define. Okay, what is the term that you use? Okay, and then explain also the how to get the 0.2% offset of yield strength. Okay, after you read about the material related to the straight stress strain curve, you will discover the 0.2% offset yield strength. So how to determine the value? So please produce this assignment 1. You need to submit by 13th of April 2021. Okay, so please produce it by using a PowerPoint. Okay, it's depend on you how many slides you want to produce. Okay, so I suggest that maybe 3 slides is enough. Okay, by using a PowerPoint. Okay, so any questions so far? Any questions? So maybe
So
I will
far, so
stop
good,
here.
doctor.
Okay, maybe I will stop here. So you have time, maybe so that you can search the information. So
Doctor, submit in PowerPoint or PDF format?
PowerPoint.
PowerPoint, okay.
Okay, submit in PowerPoint. Right. So this is assignment 1. Okay, after this we will have another assignment, assignment 2. Okay, so my part, which is assignment 1 and assignment 2. Okay, so if you don't have any questions, so I will stop here. So thank you very much. Okay, bye-bye.
Thank you, doctor.
Thank you,
Thank you,
Doctor.
doctor.
Thank you, Doctor.